This is Chapter 6, Section 1, Properties and Attributes of Polygons. Your objectives are to classify polygons based on their sides and angles, and to find and use the measures of the interior and exterior angles of polygons. I want you to pause your video, take a look at your DOK chart in your agenda, and come back after you've written your essential question. The first section talks about polygons, vertices, and diagonals. This is something review that you guys have learned before. So these are your sides of your polygons, they're straight edges. Your diagonals go from one vertex to the other, and your vertices are all the vertices, are all the corners of your polygon. You can name a polygon by the number of sides that it has. So if it's 3, it's a triangle, because tri means 3. 4, quadrilateral, quad means 4. 5, pentagon, that means 5. 6, hexagon. 7, heptagon. 8, octagon. 9, nonagon. 10, decagon. 12, dodecagon. And then once you start getting into larger numbers, we just call it an n-gon. So if we're talking about something with 56 sides, we're going to call it a 56-gon. That should have been reviewed, but in case you don't know it yet, make sure that you also memorize these words for these number of sides. Alright, so first we need to tell whether or not the figure is a polygon. Polygons have straight edges, vertexes, and sides. This one has only sides, vertices, and it is a polygon. After you figure out whether or not it's a polygon, you also have to name it by the number of sides. So we've got 1, 2, 3, 4, 5, 6 sides. A 6-sided figure, if you check the other chart, is called a hexagon. So this is a hexagon. 6 sides. And we had to say yes, it was. Alright, next we have 1, 2, 3, 4, 5, 6, 7 sides. They're all straight edges. We have vertices, vertices. So yes, this is a polygon. And what did we say? 1, 2, 3, 4, 5, 6, 7. 7 sides. A 7-sided figure is called a heptagon. This is not a polygon because these are curves, not straight lines, not straight edges. So this one we have to say no, it's not a polygon. So now we're talking about regular polygons. This is a concave polygon. Its diagonal from one vertex to the other is outside of the shape. If it's convex polygon, then all of the shape's diagonals are going to end up within the shape. So we need to tell whether the polygon is regular or irregular, and then tell whether it's concave and convex. Regular polygons have the same sides and angles throughout, and irregular have something different. So this one has the same sides, same length on all 4, which would classify it as regular, but the angles are different. See how this has 2 arc marks and this only has 1? These 2 angles are different, so this is irregular. Now, concave or convex, if I draw the diagonals into that shape, all the diagonals land within the shape, so this is convex. In this shape here, we have all of the angles being 90 degrees, which would make it regular, but it's irregular because not all the sides are the same length. Now we need to decide if it's concave or convex. If it's going to be concave, then that means our diagonals land outside the shape. If it's convex, then our diagonal lies within the shape. So this diagonal from here to here is within the shape. This one from here to here is within the shape. Within the shape, within the shape, within the shape. Problem is when I get from this corner to this corner. That diagonal lines outside of the shape, so it's called a concave polygon. The last one. All four sides are the same length. All four angles are the same measure. So that means that this is a regular polygon. If I draw in my diagonals, all my diagonals are within the shape, so it's also a convex polygon. Alright, so we have our triangle here. If you read this to yourself, if you want to pause the video, you can go ahead and do that. But we remember that triangles, if I add all the angles, if I find the sum of all the angles in the triangle, it adds up to 180 degrees. And then to find the sum of all the interior angles for different polygons, you just need to create triangles within it. So this triangle that's here is 180, and this triangle created here is 180. So I, for a quadrilateral, would multiply 180 times 2, and you'll see this on the next slide, to find out the total sum of all the angles within that shape. Same thing with the hexagon. So I have 1, 2, 3, 4, 5, 6 sides. That's why it's a hexagon. And then I create triangles drawing in all of the diagonals. And that creates 1, 2, 3, 4 triangles within. So I would multiply 4 times 180 to figure out what the sum of those angles were. And so this is the formula that we come up with using what we were doing on the last sheet. So if there are 3 sides, then there is 1 triangle. So I multiply 1 times 180. 4 sides, a quadrilateral, makes 2 triangles. So it's 2 times 180 gives us the 360. 5 sides creates 3 triangles. 3 times 180 makes the 540. If you notice, this number of triangles that I create is 2 less than the number of sides that are in the shape. So this is our formula. Whatever that number of sides is, if I subtract 2 and then multiply that number times 180, that will give me the total sum of the angles within the polygon. And that's your polygon angle sum theorem. Alright, so here's your first example with that section. It asks you to find the sum of the interior angle measures of a convex heptagon. Hept means 7, and convex means that it's not going to have any of the diagonals on the outside of your shape. So we can use our formula, which is n minus 2 multiplied by 180. It's our polygon angle sum theorem. And then we said the heptagon hept meant 7, so 7 take away 2 times 180. 7 minus 2 gives me 5 times 180. 5 times 180 is 900. So the sum of all the angles in my convex heptagon is going to be 900 degrees. Next question asks us to find the measure of each interior angle of a regular 16gon. 16gon, obviously 16 sides. So first we need to find the sum of their interior angle measures. I want to find the one eventually of each interior angle. So one angle. I'm going to start with finding the whole thing. So I'm using my polygon angle sum theorem, which is n minus 2 times 180 degrees. N is 16, it's the number of sides in your polygon, times 180 degrees. When I multiply that out, I'm going to end up with 2,520 degrees for the entire 16gon. So that's 16 take away 2 and then times 180. That's not what the question was asking me for. I need to go back and figure out what each individual angle is going to be. So I need to take that 2,520. Oops. 2,520. And I need to divide that by 16. And then you can either use long division or you can pull out a calculator, but you're going to end up getting 157 and a half and that's going to be the degree for each individual interior angle. Third example for this section, you're being asked to find the measure of each interior angle of the pentagon. Pentagon means we have 5 sides, and it's drawn here for you. So if I'm going to find the measure of all of the angles within the pentagon, I need to use my polygon angle sum theorem, which is n minus 2 times 180 degrees. Pentagon, pent means 5, so I've got 5 minus 2 times 180 degrees. 5 take away 2 gives me 3. 3 times the 180 is going to give me 540. So 540 degrees is the degrees for my entire polygon, but I wanted to find the measure of each of those interior angles, so I need to add all of them together. So I need the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D, plus the measure of angle E, and all of that, when I add all of those together, is going to equal 540 degrees. Now I know all of these measures because they're labeled on my image there, so I've got 35C plus 18C plus 32C plus 32C again plus 18C, and that's going to equal 540 degrees. Now if I combine all my like terms, I end up getting 135C equals 540. Divide both sides by 135. C is 4. My directions didn't ask for C, it asked for each of those individual angles. So my side that was, or my angle, that was 35C, angle A. Measure of angle A, 35C, so it's 35 times 4, is going to be 140. Stick that right here, 140 degrees. So that's your measure of angle A. The measure of angle B, which is also the measure of angle E. I'm going to do both of those at the same time. Measure of angle E is 18C, which is 18 times 4, which is going to give me 72 degrees. And then our last angles are C and D, which are also the same. So the measure of angle C and the measure of angle D are 32C, which are 32 times 4. 32 times 4 gives me 128. 128 degrees. So those are the last two. Alright, second theorem, last theorem. We're talking about the exterior angles now. So we already, the first theorem that we talked about, the polygon angle sum theorem, is talking about the interior. Now we're talking about the exterior, the outside. So you're extending each of the sides and you're taking that angle that's created on the outside of your polygon. And if you add all of those angles, you'll find that they equal to 360. And that's what this theorem says. The polygon exterior angle theorem says that if you add the sum of the exterior angles, then so long as it's convex, is going to be 360. So here's our first question of the next section. We have to find the measure of each exterior angle of a regular 20gon. 20gon has obviously 20 sides. So we're going to go with the sum of the exterior angles being 360. The sum of all the exterior angles of that shape. And then we're going to divide that number by 20 because there are 20 sides. The reason why we can do this is because they said it's regular. So all of those exterior angles are going to be the exact same degree measure. 360 divided by 20 is 18. So each of the measures of the exterior angles of that polygon is going to be 18 degrees. And I'm going to say one more time that the reason why I got to divide 360 by 20 was because they said it was regular. So all of those exterior angles are going to be the exact same measure. Alright, last example. We need to find the value of b in this polygon here. Now I know that the exterior angles are all going to add up to 180 using the polygon exterior angle sum theorem. So I've got, and it doesn't really matter where you start, I've got 15b plus 18b plus 33b plus 16b plus 10b, oh I'm going to run out of room, plus 28b equals 360. Again, if I combine all my like terms, I end up getting 120b equals 360. Divide both sides by 120. I end up getting b equal to 3. Oh, and that's what they wanted. They wanted the value of b. So that's my answer. If you have any further questions, please watch the video again. If you still have questions after watching the video a second time, write them down beneath your notes so that we can talk about them in class.